So let me erase this really quick. Starting on these, always on these arcsine problems, if there are problems like this and it wants you to evaluate these, it wants you to solve for x, you need to evaluate the one that doesn't have an x in it first. That's why I've got the arrow drawn to arc cosine of 0. That's evaluatable first. And right here, remember arc cosine, let me, from my pointer here, I can look at my restriction that I already had. I know arc cosine only evaluates in the top half of the unit circle, and that happens, my x is 0 at pi over 2. Pi over 2. So 3 arc sine of 2x equals pi over 2. Now I need to isolate arc sine, which is done by dividing by 3. So I get arc sine of 2x equals, if I keep change flip this, it gives me pi over 2 times 1/3, which will just give me pi over 6. And then to evaluate this, I'm going to go backwards, right? Like I'm trying to get this by itself on both sides. So you can think of doing sine to both sides. You can think of, I wouldn't particularly write that down, but I think of doing sine of pi over 6 on both sides to get this to go away. So, because sine and arc sine are inverses, and sine of pi over 6 is 1/2. So I get 2x equals 1/2. And then to get x by itself, I can divide by 2, and get x is equal, keep change flip, 1/2 divided by 2, and that gives you 1/4. So for arc sine of negative y, which labeled point intersects the terminal ray of the given angle. And on these, one thing I will say to solve problems like this, it's the one, remember, where it gives you x, y in a weird quadrant. Because normally, let me write this in red. This normally this quadrant down here would be x comma negative y. So because of that, your y's are going to be flipped on all this, like comparing this to this, your y's are flipped throughout. So this would normally be x, but then it's negative y instead. Same thing here. This would normally be negative x, which nothing changes. But on the top of my unit circle, this is y, boom. And then right here, this will be negative x as well, but it's y as labeled here. And I get all that from this point here. And once again, I'm not explaining it like fully, but I'm just trying to go a little bit quick. And it's trying to say, and it says for arc sine, and remember that's the right half of your circle. Arc sine happens on the right half of the unit circle. So I'm looking between P. I'm looking between P and S, but I only have negative y at point P. So the answer is simply just point P, because it says which label point intersects the terminal ray, and the terminal ray is intersected at point P, because point P has a y coordinate of negative y. Then here on number 6, let me make this smaller. It says let f of x equal sine x for what are the values in the xy plane between 0 and 2 pi, for which f of x, so basically sine x, is greater than or equal to negative square root of 2 over 2. So I'm going to look here on my unit circle. It's helpful to have your unit circle here. I see negative square root of 2 at 5 pi over 4 and 7 pi over 4. So right here and right here. And because it's greater and it's sine is working with the y values. So to be greater, I'm going to go from here to here, okay? All the y values there are going to be greater. And what this means is, like if I look here, negative square root of 2 is smaller than 0, and 0 is smaller than 1. So as I go up both ways, my y values are getting greater. And then the weird part that people have struggled with some is writing the intervals here. So my solutions, remember the unit circle starts at 0. So this is one of them where you have to rewrite it. So it starts at 0, and then I see where it goes to till it stops, and it stops right here. So my first intervals, I have solutions from 0 and like x is between 0 and 5 pi over 4. So all my solutions on that first part are from 0 to 5 pi over 4. And if I have multiple, I write or. And then I pick back up at 7 pi over 4 and go to 2 pi. Okay. And on number 9, this was one that I misprinted somehow. I thought I had fixed it originally, but apparently it did not save on Delta Math. The problem really, because I've got this written in terms of theta, if you want to just completely rewrite it, the problem we're going to be working with is 8, just so the numbers work out a little bit nicer, 8 cosine squared theta equals negative 4 cosine of theta. Okay, so remember, on ones like this, you can't just divide by cosine on both sides. That seems convenient, but it's going to leave an answer out. You got to get all your trig functions to a single side. So I need to add 4 cosine on both sides with the goal of factoring out something for cosine theta. So these are just going to cancel each other out, and I'm going to be left with 8 cosine squared theta plus 4 cosine theta equals 0. So now I can factor out 8 and 4 have 4 in common, as the greatest common factor, and they also have a cosine in common. So I can factor out 4 cosine from both, 4 cosine theta. 8 divided by 4 is 2, and then I'm left with a single cosine. So that's for this part. And then for this part, I took out everything. So there's just 1 as a placeholder here. Because 4 cosine theta divided by 4 cosine theta will give me 1. So, and if you struggle with that, just think about what would have to be there if you distribute it back out. And now I can set this one equal to 0 and solve, and this one, 2 cosine theta plus 1 equal to 0 and solve. So I get 4 cosine theta equals 0. And for room's sake, I'm not going to write it out completely. If I divide by 4 on both sides, I still just have cosine theta. 0 divided by 4 is 0. And then my theta values, and remember, I'm working between 0 and 2 pi. So my theta values are where cosine is 0 or my x-coordinate. So cosine is x. My x-coordinate is 0 on the unit circle. So if I go in here, let me clear this guy out so I can use it again. So 0 on the unit circle happens at pi over 2 and 3 pi over 2. So pi over 2 and 3 pi over 2. Okay, and then I can do this part right here. So that's one part of my answer. Theta equals pi over 2 and 3 pi over 2 are 2 of my answers. And then 2 cosine theta plus 1 equals 0. So to get cosine by itself, I'm going to subtract 1 from both sides and then divide by 2, which will give me cosine theta equals negative 1/2. And cosine is negative 1/2 at 2 pi over 3 and 4 pi over 3. So 2 pi over 3 and 4 pi over 3. So theta equals 2 pi over 3 and 4 pi over 3. So you would combine these. I'll do that in red here. You would combine these to get theta equals pi over 2, 3 pi over 2, 2 pi over 3, 4 pi over 3. So that's my solutions for everything, okay? Now, let me go ahead. Clear ink. Number 10, use a sign chart to solve for theta below. For your sign chart, while I'm talking about the sign chart, I'm going to go ahead and pull up my calculator. So for the sign chart, remember this is the one you will get a calculator for. So you've got to set each of your factors. So in this case, 6 sine theta plus 3, and then the cosine one, you set those equal to 0 and solve to get your values. And then you start at 0, go to 2 pi, and check values there and in between. So we'll go through the whole process together here, because I know this is probably the hardest question on the entire test. So if I go to the annotate here, let me go ahead and solve this. So 6 sine theta plus 3 equals 0. I'm going to do the same thing with the cosine one. I noticed that as soon as I wrote this down. This should have been switched as well. I made a lot of mistakes. So this should not have a square root. So really what we should be working with, I did it backwards. I don't know how I did that. I could have swore I changed it before printing, but been a long week. So this should not have a square root. So really you're working with 2 cosine theta minus the square root of 2 equals 0. So a typo on 9 and 10. So typo on 9, but also a typo on 10. Typo on 9 and typo on 10. So when I solve these, if I get sine by itself, I'm minus 3 from both sides, and then divide by 6. It gives me negative 1/2. That half theta, that sine is 1/2. Let me make this unit circle a little bigger. So sine is 1/2. Or was it? Yeah, sine is negative 1/2 rather, at 7 pi over 6 and 11 pi over 6. So 7 pi over 6 and 11 pi over 6. And then for the cosine, you would add the square root of 2 on both sides, then divide by 2. So I get positive square root of 2 over 2, which happens, go to my unit circle, positive square root of 2 over 2, is pi over 4, and 7 pi over 4. Okay. So when I go to my chart, just to remind us of what we're looking for, I'm looking for all the values that are greater than 0. So not greater than or equal to, so I only want positive values here. I only want positive values. So when I'm doing this, then I'm looking, okay, I got to write these in order. I start at 0. Let me move this over a fuzz, or zoom in a fuzz. Move it over a little bit. So I start at 0. To 2 pi. Okay. 0 to 2 pi. And then when I'm writing my answers out here, I'm going to put my points that I just found, like all of this section, I'm going to put these in order here. So like going counterclockwise on the unit circle, pi over 4 comes first. Then I get 7 pi over 6 next. Then 7 pi over 4. And then 11 pi over 6. And remember, we already know that this is all of these give me 0, so I can put their value as 0 here. It's not positive or negative, it's just 0. And then I just choose any values between this. So pi over 6 is between that. Pi is between these. 3 pi over 2 is between these. And 7 pi over 4. Now, there's nothing between 7 pi over 4 and 11 pi over 6, so I'm just going to use 7.1, just 0.1 more, 7.1 pi over 4, Same thing with 11 pi over 6 and 2 pi. I'm going to use 11.1 pi over 6. So, and now all I've got to do is plug these values in. So I'm going to plug in, I'm using this whole entire factor here, this factored out equation, and I'm plugging in. So let's see here. 6 sine, and for theta, I'm going to put 0, and I'll do the first two of the sine chart, and then just leave you to plug the rest in. So 2 cosine of 0 minus the square root of 2. That gives me 1 point something. All I care about is that it's positive here. Okay, positive. And then when I'm looking at this next part, I would plug in for pi over 6. So go up here. You don't have to insert like this, but you can go second insert and do, go here and just make this a fraction. So delete this. So I can put in pi over 6, pi over 6. Delete this. Oh crap. So sorry about that. Not as easy to do on a keyboard calculator. And change this to fraction pi over 6, which is also positive. And so you would just plug in like that for the rest of them. And I'll fill out the sine chart. You can pause and do this if you want to practice with it. Just for the sine chart, I know this is negative, this is positive, this is negative, this is positive, and I'm pretty sure 2 pi should be positive as well. So I'm looking for values when it's greater than 0. So right here, I made a small little mess up on the answer key. It wouldn't matter, like you'd be able to tell on a multiple choice test. But since 0, like I'm looking for all the values where it is positive, so when I write 0, it's actually equal to there. That's 0 and 2 pi are going to be equal to, because it's actually equal to a positive at those values instead of a 0. And I'll show you what I mean. So theta is less than or equal, 0 is less than or equal to theta, is less than or equal to pi over 4. But that less than or equal to, remember, the difference is here, I don't use that equal to. I don't use it equal to because at pi over 4, my function's value is 0. My function's value is 0, which is not a positive value like it wants. It's not a positive value like it wants. So if I write this out then, I can write that, or my next positive value is from here to here. And remember, at the endpoints, they're not included because they're not positive. They're 0 there. So I would say, or 7 pi over 6 is this. Oh, just by having to write the equal sign. Sorry. Just trying to finish up before the bell. Or from 11 pi over 6 to 2 pi. And at 2 pi, it is positive, so it's included.
Just a couple announcements before we move into 7th period. As far as